Hello. Good afternoon. Welcome to Bringing Existing Managed Code into Metro-Style Apps. My name is Daniel Plaisted. I work on the base class libraries team of the .NET framework at Microsoft. I joined Microsoft about 3 years ago because I really loved the developer tools and platform that Microsoft provided. And now we've been working for a while on, a new platform and developer tools for Windows Metro-style apps. And I'm excited to be here at Build to finally be able to show that to all of you. And you could say that I am indeed super excited. So what we're going to do today is we're going to look at how to take an existing managed app and bring it into Metro-style. So the app that we're going to look at today is a XAML-based app. So who here does XAML development? Most of you? Maybe half, hopefully more. And who has heard of or is familiar with the model view model pattern? Also, most of you, or even more, it seems like. So that's good. The application that we're going to port uses this pattern. And so it will help if you're familiar with just the basics of XAML-based development and the basics of the model view model pattern. If you're not, we will go over briefly the basics of the pattern. But if you've never heard of it before, it'll be kind of like getting bombarded with lots and lots of information. But you're probably used to that, considering all the stuff we've been talking about in the keynotes and big picture sessions over this conference. So what we're going to do is we're going to start out by talking about, just in general, what does this Windows Metro-style platform mean for a managed developer at a high level. And then we're going to look at the app that we're going to port. And this is, like I said, it's a XAML-based app, and I may not have said it, but it's a phone app. We're going to look at that, both how it works, and then we're going to see how it's implemented. And as we do that, we'll see how the view model pattern works. Then we're going to look at, well, what are some strategies we can use to port that to Windows Metro-style, and what are some issues that we're going to encounter as we do that porting. And then we're going to actually go through the process of the port, and we'll see each of those issues, and we'll see how to resolve them. So that's the basic overview of this session. This is an interactive Chalk Talk session, so I'll be stopping at several points to ask if there's any questions. And if something's not clear, feel free to try to interrupt me and ask a question. So let's get started. Windows 8 introduces a new app development platform for Metro-style apps. These are vibrant, fast and fluid apps that fast and fluid apps that take advantage of everything that Windows provides. New hardware, new OS capabilities, the full screen to really engage your users. For managed developers, you can use your existing .NET skills to write these apps. So C# and Visual Basic are totally supported languages, and you can describe the user interface with XAML just like you're used to. And because of that, you can bring your existing code forward to .NET Metro-style apps. Now, it is a new platform, so there will be some changes that you'll usually need to make, and we'll see the most common of those changes today and see what we need to do. So let's look at our app. It won't disturb me at all. So he's saying there's a lot of people outside. We're going to open the doors so they can hear, hopefully. It looks like the session is being recorded, so hopefully it will be online later also. So let's look at this Windows Phone app that we have. So this app is a flashcards app. So this is to help you memorize, in this case, either objects in the solar system or world monuments. So shall we take a quiz on the solar system or on the world monuments? I heard both. I'll pick monuments. So the app now shows us a picture, and we have to think of what is this. So does anyone know what this is? Machu Picchu. Very good. So we tap on the screen, and it displays the answer, and then we can record, well, did I get it right or did I get it wrong? So this is, a touch-based interface, so it makes a lot more sense to think of the answer in our head and then tap, did I get it right or wrong, instead of like typing the answer. So we got that right. What is this? Grand Canyon, exactly. Okay, so we could continue to go through these flashcards. We can also use this command at the bottom to jump to the end of the quiz, and we can see our results. So yay, we got 2 out of 2. So this is a very simple app, but we can also edit the lists. So we've got these controls at the bottom here, and we can go to edit mode, and let's edit the solar system. Now, we've got some objects in the solar system here, but does it look like there's something missing? Pluto. So let's add a new card. So we're going to choose an image. This is going to bring up the image picker from Windows, and we see Pluto. So let's choose him, and then we'll give the card a title. Pluto. There we go. So now we go back, and it's saved. So that's the basic functionality of our app. We can take quizzes, we can edit cards, and of course, for the editing to be any use, of course, we need to save it. We need to persist that data, and this app also does that. So now that we've seen what the app does, let's take a little bit of a look at how it does that. As I mentioned, this is a model view model app, or this is a pattern that's also known as MVVM, or just view model, which is what I call it a lot of the time. Now, this is a popular pattern when developing XAML-based apps, and what it allows you to do is separate the UI from the rest of your code, the rest of your logic. So that has a lot of benefits. It's just generally good from a separation of concerns point of view. It lets you test your logic without having to worry about UI automation because you have that separation. It allows developers and designers to work together. The developer can work on the logic, and the designer can work on the view, the XAML, without stepping on each other's toes. In general, it just helps you develop consistent, maintainable, and scalable applications. And we're going to find out that it actually, in our case, is going to help us with an application that's going to be easier to port, because we're moving this from the phone to Windows Metro style. So the interface should be different. So we actually want to create new UI for this application, but we want to keep as much of the application logic as possible. So since we've split those out cleanly, that we can do that with the view model pattern. So if we look at the code here in Visual Studio, I guess I'm pointing here, you're looking over there, we see that we have different folders in our solution, and we've got folders for the model, the view models, and the views. So let's just go back to the PowerPoint for a second and talk about what that means. So this is a slide I borrowed from John Papa and adjusted a little bit if you're familiar with him. But these are the 3 elements in an MVVM application. And basically what you do is you separate the what you're going to display from the how it's going to be displayed. So the view model controls what will be displayed, and that is a class that exposes properties and commands that will be shown and reflected in your view. But it doesn't say how they'll be displayed, how they'll be styled, or anything. And then you have your view, which is mainly XAML, and it displays those elements. And via data binding, it gets those properties from the view model. And the view model, of course, is going to get what it should display from your data objects, which are basically your model. So this is your data and your business logic, and anything else that's not directly related to a screen that you're showing. So let's look at some code for how this looks. We've got on the left, we've got the view, a snippet of the code from the view for the home screen, and then we have some snippets from view models over on the right. I guess you can't see that pointer very well. In any case, the main element that we have on the home screen is a list box, which shows the quizzes we can take. And so that's declared in XAML here, and we can see we're saying the items are coming from this binding, which is bound to a lists property. And that lists property comes from our view model over here. So it will pull the items from this. Now, we want to control how each item is displayed, so we have an item template for this list box. And inside that item template, we've got an image and a text box. So we want to show the image, which is like the first card, and a text block, which is the name of the quiz. So these are likewise data bound, but they end up being bound to the element that is the member of this list. So we've got list of flashcard list view model here, and then this is that class, and it's got these properties which are being data bound to elements in the item template. Does that make some sense? I guess most of you are familiar with this, so are there any questions at this point? Let's move on. I think the next thing we want to do is actually look at some code. So this is pretty general to just the view model pattern, but within the view model pattern, there are lots of different ways to do other things. So one of those things is navigation. So what we're going to look at now is how I've chosen to implement navigation in this application. It's certainly not the only way, but let's just look at how it works. Once I press this. So here we have a view model for the quiz. And when you tap on a quiz to start a quiz, it's going to invoke a command which is going to call this method. And we can run it and see what happens. So we'll start a quiz for the solar system, and we hit the breakpoint. So what we're going to do is we want to move to a new screen. So we've got an association for each of our screens. We've got a view to display it and a view model to hold the data. And the way we move between those screens is we have a navigation service. And what we do is we construct the target view model, which we're doing here with this new quiz model, that new quiz view model. And then we tell this navigation service to navigate to that view model. Now, this navigation service is something that I've written for this application, and it keeps track of how to navigate to each view and view model, and it keeps track of the association between each of those. So when we tell it, navigate to this view model, it has a list or a dictionary, and it looks up, well, what's the corresponding view I should go to? And then, of course, we run it, and obviously, it's going to take us there. So just how have we set this up in our application? Well, in our startup code is where we're going to create this class which implements this navigation. So the class which implements this navigation service I've called ViewModelConnector because it's connecting the view models to the views. And then in our startup code, we basically create a new instance of that, and then we tell it, well, here's a view model type that maps to this view. Now, in Silverlight for Windows Phone, the way you do navigation is via a URI. You pass it a URI to say, go to this view. So that's what we're passing in for the view. And then we just create our home view model so that it will be able to start the app. OK. Any questions at this point? I guess I'm covering stuff that's old hat to you guys. Let's see. So now that we've seen kind of the app that we're going to port, let's talk about how are we going to actually manage porting this code to a Windows Metro style app. So there's several different strategies you can use. And in any decent sized project, you'll probably do some mixing and matching. But basically, you can start from scratch. You can create a new Metro style app. And then you can start development there. And as appropriate, you can copy and paste code in from your old project. Another strategy you can take is copy everything. So here you're also going to create a new project. But then you're going to take all of your files and just dump them into that project. And then bit by bit, you're going to fix any errors that you come across. And then eventually, you'll have a working Metro style app. So that's what we're going to show how to do today. We're going to walk through that process. You can also use shared code and conditional compilation. So this is basically, those first two options, you end up with two separate code bases. And if you want to continue development on both applications, that's probably not ideal, because you'll have to duplicate the changes in each code base. So one way to manage that is via sharing the code. You'll have two separate projects, but you'll use the same source code files. And this is a common strategy today. Where you can use Visual Studio's linked file support. You just say add existing file, and in that dialog you can say add as link. So instead of copying the code into your project, it will just use that same file. So, and then you can use conditional compilation, a pound if in C# to account for any differences. Finally, you can use a portable class library. This is a new feature that we've shipped as an extension to Visual Studio 2010, and in Visual Studio 11, it will come in the box. This allows you to create a single project, which will create a single DLL, which will run on multiple .NET platforms. So what happens is you create this project, and then in the project properties, you can select, well, these are the platforms I want to target. Windows Metro Style, Silverlight for the phone, but none of the others, which include, the desktop and Silverlight and Xbox. So you have those options. And then what you'll be able to use from that portable class library from the .NET framework is, a subset of the APIs that are the same across all of the platforms. So this is, in some ways, kind of the best option, but the problem is you're restricted in the APIs that you can use, so it won't be usable in all cases. Moving on, what are the kinds of issues that we're going to run into? So here's kind of the overview. So the UI namespace is different. Instead of system.windows for the UI types, it's windows.ui.xaml. So we'll have to make that change. The UI stack is now Windows runtime, which means it's native and can be used from .NET, but is not .NET based. So there'll be some issues where there'll be differences between types, and we'll have to fix those. There's some types that behave a little bit differently. The ones we'll hit are URIs and navigation. We'll see how to address that. And then just in general, the platform is different, so it handles application cycle differently. The way you access files is different. And there's facilities that the operating system provides, like the picture chooser, which are going to be different. So we're ready to port this application. Any questions? Come on. You cannot. Well, you can, but it will fail the certification process. Sorry. The question is, can you take a regular old .NET assembly and reference it from a Metro-style application? And the answer is you technically can in Visual Studio, but it will fail the certification process because it will access APIs that aren't supposed to be used from Metro-style apps. Anything else?
So, just along with that, so are they going to be recompiling up the whole base class library to be accessible?
So the question is, are they going to be recompiling the whole base class library? The quick answer is no. The long answer is you should go to Christoph Swalina's session on Friday, and it'll explain how this works. So I think I want to switch over to this computer, laptop. There we go. So now we're in Windows 8, and we have Microsoft Visual Studio 11 Express for Windows Developer Preview. So we're going to create a new project for our flashcard application. And we'll call it Flashcards. OK? New project. And now we want to take our existing code and copy it in there. So I have the phone project on this computer. And now remember what I said, the views, we're going to write new views for our Metro-style app. But most of the other code we're going to take. So the only other code I'm really not going to take is that application startup code. But we'll see how we write that. And it's the stuff that we added to it will be very similar. Models, view models, not views, and view model connector. So we're going to paste these files into the directory for our project. And then now we need to actually add them to the project. The easiest way to do that is to click on the project in Solution Explorer, and click on Show All Files. And then we can just hold down Control and multi-select everything we want to add. OK, right-click, Include in Project. So there we go. We've got our code in our new project. Now, when we try to build this, what do you think the first issue we're going to run into is? Namespace. Wow, good job. So we'll get a whole bunch of namespace errors. about 88 of them. So this is, you know, a whole bunch of errors, but it's very simple to fix. We're just going to do a global find and replace. System.windows, replace in files with windows.ui.xaml, or replace all. Okay? Save that, close that, build again. Okay, isolated storage. Like I said, the storage APIs are different under Windows runtime. One of the reasons for that is you've heard about async. You know, we want to make sure your Metro-style apps are responsive, so that's part of the reason they're different, and the isolated storage API isn't available. So this is our repository that handles saving and loading our cards. And it's, you know, probably some of the biggest code in this application, actually, and so it's going to be kind of complicated to port. So when we're porting an app, if we run into something like that, you know, we want to get the basics working first. So if you come across something that's harder, then you probably want to remove it or stub it out or do something that lets you just get a basic running app, and then you can come back and address that. So we're just going to comment this all out. And because the way we've developed it is it implements this interface, we also have another implementation, which is the default repository, which doesn't support saving, but it will load that, you know, the prepackaged list of cards that come with the application. Okay? So save that. So now we've got issues with iCommand and our converter, which are, you know, common things that you use when doing XAML development. So what's the issue with iCommand? It says we're not implementing can execute changed. Well, we have it right here. What's the problem? Let's go to the definition for iCommand, and we can see that can execute changed is windows.ui.xaml.event handler. So this is a WinRT type that the event handler is on this interface, because this iCommand is also a WinRT interface. But down here, event handler is binding to system.event handler, which is a .NET type. So that's just one of those differences between WinRT and .NET, but it's easy enough to fix. Okay, and then the other one was in our visibility converter. So, you know, if you've done XAML development, you know what this is. This allows you to use a Boolean on your view model to control whether a control is visible or not on your model. So it converts from a Boolean to a visibility enum. What's happening here is this is a Windows runtime concept now, this iValue converter. And so these parameters that are the type and the culture info don't map as directly into the Windows runtime native type of interface. So we can see in the error that it says, you know, the signature we're supposed to implement is object string, object string. So these types are represented as strings in the WinRT interface instead of as, you know, type and culture info. Since this is a very simple converter, we weren't even using these, so we just change the parameters here. Okay? Yes? It's the full name, but not the assembly qualified name. So the question was, what, if you do need to use that, what is that string name of the type? And the answer is, it's the full name. For culture info, I'm not entirely sure, but I think it's just like en-us or whatever it is. But I don't have personal knowledge of that. Yes? So the difference between the event handlers is just one is a Windows runtime version, and one is like the .NET version. So it's just two different types. And if you look at the signature for the Windows runtime version, it actually doesn't use event args for the args. It just uses object, for example. Yes? For what? Yes. Okay, yes. So the question is, which of Microsoft's .NET assemblies can you link? And the answer is also come to Christoph's session tomorrow. But basically, we have a set of reference assemblies which are just for compile time, and they encapsulate the APIs that you can access from Windows Metro style. And so actually, when you create a Metro-style app, all of those will be referenced automatically. So the entire .NET surface available to you is already referenced when you create a Metro-style app. Anything else? Yes?
So the type is a string, and you said it's the fully qualified copy assembly. Since this is for C++ and C#, is it going to use either notation?
I don't know how it works for C++.
But if you're writing stuff that can work across languages,
Uh,
you wanted to parse that string out and have it be initiated from a C++.
Sure. I don't really know, so I can't answer. I'm sorry. You know, I'm going to be around afterwards, and we can follow up to find the answer on that. Let's move on. So now we've compiled, and we've got a bunch of errors in this data context changed helper. Well, this is actually something we don't need in our case for Windows Metro style. This was working around the fact that on Windows Phone, you can't data bind to stuff in your app bar, so we had to do some stuff manually. But you know, we don't need this, so we're just going to comment this out. And that's because, you know, on the app bar for Windows Metro style, you can do full data binding, so we don't need that workaround. So finally, now we land in our view model connector. So this is, again, what handles the navigation. And the issue that we see is that navigation in Windows runtime, if we look at what is it expecting, it's expecting a string. So just like, you know, on the converter, the type was expressed as a string, that's the same thing here. So what we need to do is, instead of mapping from a type to URI, in this class we need to map from a type to a string. So we're just going to do that with, you know, lots of replaces. Whoa, string. Copy that. We're mapping, changing the string, same mapping, constructor, string. Here's the event args. It no longer has a URI. It has a type, which is, of course, a string. And so this is the method we're going to call to make that mapping. So we actually don't want to pass in a string to this method because we want to keep it strongly typed. So we're going to pass in a type for the view, but then we'll take the view.fullname. And likewise, this is now a string. So that's fixed that part of this class, basically the navigation part. There's one more issue, and that's we're using the dispatcher to basically post a message that will be executed later. And that's because we don't want to start a navigation while we're still in the middle of a navigation. That can cause problems. So the thing here is just the API has changed slightly that Windows Runtime offers, and it's now dispatcher.invoke async, and it has some additional arguments to control like the priority. So we just need to use that new different method. So that, I'm just going to copy that code. There we go. Oh, let's prettify it a little bit. And it didn't. Oh, well, it doesn't matter. OK. Well, I mean, it's just formatting, right? We're not going to look at this again, so. OK. Ooh, it built. So now we've got, our models and our view models basically converted to Windows Metro style. Of course, we have no views. So when we run the app, we're just going to get this, this main page, which has nothing in it. So now we need to add some views for our application. And of course, the first one would be the home screen. So let's create a new folder for our views. Add new folder, views. And now we're going to add a view. So add new item, Windows Metro style. And the home screen is displaying a collection, basically, of the quizzes you can take. So the collection page template makes sense. So we'll take advantage of some of the design work that's already been done, so it makes it easier for us to get a decent UI. Home view dot XAML, really. OK. So now we have a basic template, and now we need to wire it up so that at startup we'll navigate to that. So on Windows Phone, you always have navigation, and you know, in XAML frameworks, a frame is what you use to navigate. On Windows Phone, there's always a frame provided by the system for you. On Windows Metro Style, you can choose whether or not you want to use navigation. And so if you do, you want to put a frame on a page. And we already have this blank main page, so we're going to put a frame on this page. And then the pages that we navigate to will just go inside that frame. So frame name equals content frame. There we go. So there's our frame. Now we actually need to pass this to our view model connector because it's what handles the navigation, and we want to do that in our startup code. But just declaring it in the XAML doesn't make it public. So we'll just add a simple wrapper property out here. So public frame my content frame get return content frame. There we go. Okay. So then let's look at our startup code. So, you know, this is the startup code for a simple Metro style app. Create a page, set the content to it, and activate it. We're still going to do that, but we're basically going to add in the code to create our view model connector, initialize it with the mappings, create the home view model, and go to that home view model. So that looks something like this. Copy that. So let me just comment that out. And then, you know, we need using statements. So just Visual Studio tip, you know, squiggly with this thing, control period, brings up that. So easier than to try to hit it with the mouse. Nice keyboard shortcut. Okay. So what have we done here? Again, you know, this is basically the same code that we commented out. We're just keeping a reference to the main page. And then, you know, we're creating our view model connector, and then we're doing the view mapping. Now, we've only created the home view, so I've got the other ones commented out for now. And then, you know, we create our initial view model, and we say navigate to it. Now, this initial view model, you can notice that we pass it a repository, and notice we're using the default flashcard list repository. So on the old application, we were doing basically the same thing, but we were using the persisted version, which for now we've commented out. So now if we run this, we might expect to see this home view on the page. We'll see that we'll run into two issues before we actually can see it. So we're running it. We're running it. OK, so the first issue has to do with the URI. We're creating a relative URI, and this is to basically our content. We've got in our app content, we have these images, and we're passing this path, which you can see there, to the image file. We're using a relative URI, which the Windows runtime or the XAML stack or whatever doesn't support relative URIs. It doesn't give you that ambient context of, oh, it's relative to my app. So we need to create a full URI. And the way we do this is on framework element, there's a base URI which says, well, where was that loaded from? So that's what we need to use here to construct our full URI. So the way we're going to do that here, whoa, that was loud, sorry, is we're just going to grab that base URI off of our main page and store it in a property that's just accessible to everything. So public static URI base capital URI get private set. Okay? And then base URI equals main page dot base URI. So now we've created a public static property which we can access from anywhere in our app. And that's what we're going to do here. So we're going to say URI is new URI app.base URI, comma, and then the relative path. And that is the overload that we're using. OK. So now let's run it again and see the final issue that we should run into before we see something. We see a blank screen. What's happening here? So if you're using navigation, it's a good idea to hook into the navigation failed event. And we've actually done that in our view model connector, and it's telling us navigation failed. So in this case, what's happening is when you navigate to something, it needs to be a page. Unfortunately, in the developer preview, the templates that we have actually create user controls. So that's why the navigation was failing. So, you know, I think everyone who writes an app with navigation will probably at some time run into this. So you just need to remember, oops, it needs to be a page. Okay. Running it again. And yay, we see our, you know, application title, the template. So we don't see any content because we have, you know, the view model connector is hooking up our views to our view models, but we haven't done the binding correctly. So that's what we're going to do next. The template does have the facility for displaying a collection of items. We just need to do binding. So where this template gets its items from is a collection view source. Okay, so just like in the home view for the phone, we bound the you know, the source or the item source of the list box to the lists property on our view. We just do the same thing here. Items or just source equals binding lists. Okay. So now we've created that basic data binding. And we see some pictures. They're not really, oh, yeah, thank you. They're not really displayed in the way we might like to see them. But we see some pretty pictures. So now we want to change, well, how is this displayed? And that's in the item template. So grouped item template, in this case, is what we're looking for. So this is what's displaying it. And we can see that the template has an image and some text blocks. And the image was already bound to an image property, which was what we were using on our view model. So that's why we saw the image without any changes. But the name is the property used to display the name of the list, and it's not bound to that. So we can just say name there. And then, you know, the images weren't centered. We're using this uniform to fill stretch. So let's center it. Horizontal equals center. Vertical alignment equals center. Okay. So running it now, we should see some centered images and some text that tells us, well, what are these flashcard lists? Okay. So we've gotten our first view basically working. It doesn't look too good, but we've seen how we start the process of, you know, editing this XAML template to get what we want there. And we could continue to do that, and that's what I've done. Or we could, you know, pass it to a designer that we work with, and they could, you know, work their magic on it and make it look great. So we will jump forward into the process to the point where, you know, we've designed all of our views. So let's open a project, which is just this basic project, but now we've added views for each of our screens, and we've made them look a little bit more like Metro-style apps. They're not entirely fast and fluid, but, you know, they're not ugly, hopefully, either. I don't know. I did them. Maybe you don't agree they're not ugly. Wrong place. Build. So flashcards with views. So questions at this point? Does it make sense so far? Okay. So here, same project. We just now have all of these views, and, you know, we've put some styling resources in the app.xaml and used them from all of these views. So now if we run it, now we see it looks a little bit better. You know, we've got some styling, we've got a color theme, text that you can read, and we've got the different views. So now if we tap and take a quiz, now it takes a quiz. So if you remember from the phone app, what we would expect is that we can tap this image and see the answer and say, well, did I get it right or wrong? I'm clicking, nothing's happening. What's going on here? So if you're actually porting code, this is something you may run into too. And, you know, we have a visibility property on our view model, which controls whether the controls are displayed on the view. And there needs to be a way of notifying the view of changes. And the way that's done is in an iNotify property changed interface. And that just lets you raise events that say, well, this property changed. And our view models implement that interface. And they do that by deriving from a class in our infrastructure that we've called property changed base. Okay, so our views, or our view models, sorry, are sending these messages. Why do they not appear to be getting to the views? Well, this is another issue of, WinRT versus .NET. There's a different type. So iNotify property changed in .NET is in system.component model. But if we delete that and use this namespace helper, we can see there's actually two versions of it again. So instead of the system.component model, we use windows.ui.xaml.data.inotify property changed. So that'll fix that problem. And that's just another thing that if you're actually porting code directly like I am, you may run into. If your changes aren't reflected, check to make sure you're using the right interface. Because it's a developer preview. The question was, why does the other one show up if it doesn't work? And the answer is because it's a developer preview. So now we can go here and we can actually see correct, incorrect. And then we also have an app bar. We can jump to the end, see the results just like we did before. We've got edit commands. You can see all of these. So we've got the basic functionality of our app. Now we're at the edit screen. If we were to go back, that's when it's going to actually try to save this, and we'd see, boom, we get an exception, because this is the default repository, which doesn't actually support saving. So we're going to look at how we would change the repository, not by walking through it, but just by looking at the finished result. But questions, comments? Yes? In the views, the views are quite different. The basics of data binding are the same, but the XAML is based on a template that complies to the Metro style guidelines. Yeah, I didn't really copy any code between them. You may be able to copy code, but in my case, I didn't. And in most cases, you don't want to try to take the same UI, especially from the phone, because that's a different screen size. You want to adapt it to Windows Metro style. But certainly, depending on your app, there could be, some things that you would be able to copy snippets from. Other questions? The question is, how close is it to WPF? And if you have a well-designed app, can you take all the XAML over? I don't think you can. I haven't done that myself, but there's some controls that aren't supported, some namespaces that are probably different. So just like the code you had to make changes, you'll definitely need to make some changes to the XAML. And I can't really speak to how much that will be. The question is, but it's roughly the same as the changes we had to make to the code. I really don't have an answer to that. I mean, you can guess that probably, but I can't answer for sure. Yes?
I haven't really seen anyone talking about differences in the binding capabilities of Metro style apps as compared to either the phone or WPF. I know there are differences in the different frameworks. Could you elaborate on that?
The question is the differences between binding capabilities in the different frameworks, and what are the differences, especially in Metro style. That is another question I don't know the answer to. So there's lots of people from the the XAML team giving sessions, so they will probably know. And of course, you can come by the booth or just find someone who knows. I think there was a question further back. Mm-hmm. The question is, when I was referencing the iNotify property changed from component model, was that from the full framework or was that, you know, from the subset? And it's building against the subset, so that is something that is included in the subset currently. At runtime, it's always against the full framework anyway. Yes? The question is WCF available? And the answer is yes. Not all of it is necessarily, and I'm not really familiar, but the basics should be there. For example, you know, the server-side stuff isn't going to be there. Okay? So there's basically two more things that we need to make this a, you know, to get back to the full functionality that we had. We need a way to choose a picture, and then we need a way to save the lists. So we're going to open up the project with that already done and look at what we had to do. So this is in the edit flashcard view. So this is the screen where you edit the flashcard. And the way we've done this is, you know, we've said, well, we'll let the view handle, you know, the integration with the OS for, you know, picking an image, and then they'll just set a property on the view model. And so this is the API you use in Windows runtime in Metro style apps for choosing a file. So it's, you know, it's pretty simple. The only, you know, slightly different thing is that it's an async method, but that's actually good, keeps your application responsive, and it means you don't have a model like you have on Windows Phone where, you know, you call it, but your application may be terminated, I guess, and then you have to worry about resuming the state and hooking into the event handler fast enough to get the results of the choose. So, you know, await, pick single file async is what gives us the image. And that gives us a file, of course, and then we're awaiting opening that file to get a stream, creating a bitmap image from that, and then setting that on the view model. So this is kind of the, you know, integration with the OS. How do I pick a file? Well, this is how you do it. And obviously, it's a little bit different than Windows Phone or, you know, Silverlight or .NET, but no big deal. The final thing we'll look at is this flashcard repository. So this does a lot of file saving operations. And like we've talked about and you've heard in other sessions, these are all async. So the first thing we need to do is, since this is all async, we're implementing an interface. We'll actually need to change that interface to be async. So if we go to that interface, we can see that, you know, now all of these methods have async at the end of the name, like the convention dictates, and then they all return tasks. And then in our implementation of this, just quickly, if you want something similar to isolated storage, you want, you know, a location to save your app's data, you can get that with this API, application-data.current.local folder. And that will give you a storage folder, and from there you can get storage file and do all of the things you want to do with the file system. One other thing to look at, what we're using here is we're using data contract serialization to save our lists of cards. This is kind of another thing where it's kind of like WinRT versus .NET. So in WinRT, all of the, you know, file methods are async, but we have this this data contract serializer, which has synchronous, you know, read and write methods. And so what you need to do, at least in the developer preview, is because those are synchronous, you need to run those on a separate thread. And so, you know, here we have await task.run, and then we're using this synchronous data contract serializer method in here. So, you know, with the await support and task support, it's pretty easy to do. But, you know, if you don't do that, then it'll actually deadlock when you get to there. So that's, you know, just the state of things in the developer preview, and that's how you would work around it. So any questions? We're about to go back to the slides and wrap up, I think. Yes?
So instead of porting, can I take existing project, the solution, so that I want to keep the old view, and then I want to add a new view, which is Metro style view.
Mm-hmm.
But the old view
Yeah, the question is about, if you have an existing project and you've got old views for desktop apps or whatever, and you want to combine that with new views for Metro-style apps. So you need a separate project for a Metro-style app. But there's different ways that you can share code between them. You can, and this goes back to the slide I talked about, you can share the code files between the separate projects and use conditional compilation to account for the differences. Or you can create a portable library project that is the common logic. So you'll have like a common project, which will have the common code, and then you'll have the two projects which will reference that. And each of those projects, one will be for Metro style and one would be for your existing platform. Yeah?
Portable one? What kind of a library is it? Is it an RT library, a custom RT library that gets created, or will it be a
So the question is, if you create a portable class library, is it WinRT or is it .NET? It's a .NET library. So it's a DLL that's created, and it's a .NET DLL. And it will work on Windows Metro style or the existing .NET platforms, depending on what you've chosen in the properties. Yes?
Do you have since Mango now has a simple database compact, do you have that same thing with WinRT?
The question is, Mango now has simple database support. Is it in Windows RT, Windows Metro style? The answer is no. You have file access, and I do not even know if you have remote database access, but I know that there's no local database. Back there?
What's the best place to get a summary of what has been cut from .NET converted to WinRT?
The question is, what's the best place to get a summary of what's been cut and what's different in WinRT? Two things. So first of all, Christoph's talk tomorrow will talk about a lot about that. And let's move back here. No, let's move back here. No, I do not believe it is. The question was, is the talk in this room? No, it's in at least a slightly bigger room. PowerPoint. Okay, so the other answer to that question is there's this page here on the Dev Center that talks about, it's the .NET for Metro style apps overview, and it talks about converting your existing code and the kinds of changes you'll need to make. So it has, replace this with this. So you'll see an overview of the kinds of changes we'll make. Let's just move on so I can finish my presentation, and then we'll have more questions as we have time. Okay, so just a summary of what we saw. This is basically the same slide. We saw some differences, but these are going to be like the common issues that you'll probably hit. So, I think this covers most of what you'll need to get off the ground. For more information, there's some more sessions, and this one at the bottom here is Christoph's session that I've been referring to. I think that may be the only one that is still remaining. I think the other ones have already gone by, so you can look them up, watch them online. Again, there's this documentation for .NET for Metro style apps, which has kind of a porting guide, what the differences are, how to deal with them. If you watch the BCL blog, we'll probably have a link to or have a post there that may give some more detailed information and may also have kind of a library to help you out. So watch that, watch the BCL blog, and we may have something there in, I don't know when, but next few months maybe. Here's my contact info. So, as we show you this platform at Build, what we're really looking for is we're looking for you to make great apps with it, and we're looking for you to give us your feedback and tell us, where is it great, and especially where is it not great, what needs to be improved. So, my call to action is go make great Windows and Metro style apps, and then tell us what the issues are. When you make these apps, don't just port your app. Think about how can I take advantage of this new platform, and how can I make a really great Metro style app. And then for feedback, you can send feedback to me, of course, or post it on the Dev Center here. There's forums, there's a place for bug reports, and if you like the session, please go submit session feedback. So thank you very much. We'll have So we've got 7 more minutes. So we'll have questions here. Then after that, I'll be at the .NET Framework booth for about 2 hours, and so you can come talk to me there. I'd love to talk about the portable libraries, the view model pattern in general, portable view models, or whatever else you're interested in. So thanks. Yes.
Does Microsoft has a roadmap to previous tool automatically support the old products?
The question is, are we going to have a tool or something that will help you automatically port? The answer is not really. We're thinking about creating kind of a library that will help you, that will either have kind of like wrapper functions that will expose the API, or that will at least have like an obsolete message that will point you to the new API you need to use, but nothing like an automated tool that I'm aware of. Yes? Go ahead. What was no ADO.NET? The question is there no ADO.NET or entity framework in Metro-style applications? And the answer is I really don't know. So come by the .NET Framework booth and we'll figure it out. Yes?
We have WPF applications, and I'm not too interested in the new Metro right now because they're thicker apps, but I do want to talk to the camera easier and use the async stuff. Can I do that?
The question is, in a WPF app, can I use these, WinRT interfaces to, use the camera and do that in an async fashion so that it's easier? And the answer is not in a supported way at this time. Yes?
A lot of phone apps have a fair amount of HTTP web requests going on, and data calls and stuff. Do you know the level of compatibility in that networking stack?
The question was about the networking stack and phone apps with HTTP web request and OData. I do not remember well what the compatibility is there. There are WinRT APIs for that, which of course aren't compatible, and there is either a .NET API or there's something for .NET, but I can't remember which API it is. I think it's instead of HTTP web request, it may be web request. I can't remember. You should come by the booth and hopefully we'll be able to answer. Yes? Not really. For large applications, no. But this is kind of just the demo of what the differences you'll see. So the question is the user story, portable libraries instead of copy-paste code? And the answer is we'd like it to be, but the issue is that in a lot of cases, the APIs that you need to use may not be available in a portable library. So if there's just a few of those, you may be able to, abstract those dependencies away and inject them into a portable library, but it is going to be a little bit more complicated. So there's various options. Portable library is one, and the linked code files with conditional compilation is another. Those are for like a real project where you've got 2 different applications that you're continuing to develop. Those are the 2 that I'd use for most of the code. I mean, you don't want to copy and paste on a large scale, but your views are likely going to be different. You may end up copying snippets of code between them. The question is, what's the story about porting controls? The answer is I don't really know. I'm actually not very much of an expert in XAML development. What you saw today is the basics, and this is most of what I know. So come by the booth and we'll try to answer the question. The question was about HTML and CSS Metro style apps. You can build Metro style apps using HTML and CSS, and there is kind of a divide there. You can't use XAML and HTML for the UI in a single application, but you can reference .NET code from a JavaScript/HTML application. You just won't be able to use the XAML framework in that code. Back there. Okay. So the question is, is it managed or is it native? The answer is the APIs that you're calling from WinRT, those are all native, but all of your code is really managed. So, the C# code that you write will be compiled to IL and will be run under the CLR. So, yes.
As a follow-up on that question, is it the same CLR, or is it a special CLR for Metro and a special CLR for the desktop?
Yeah, the question is it actually the same CLR that's running for Metro style apps? And it is. The implementation is the same. I mean, sure, there's going to be, in the code, there's going to be different code paths that may be running, but it's the same code. Yeah, you should go to Christoph's session to get the details of how that works. Yes? So there may be some that I don't know of, but I don't think there are. Basically, not really anything. It's just the interfaces have changed. So it's using a WinRT interface, and it turns out that the signature of the can execute changed is different. It doesn't have event args. It has object. But that's really all that I know that's different.